Good evening, everyone, and welcome to the 13th episode of the Our Futures Foundation webinar series. I am Anna Jamila, the webinar coordinator for the BH Futures Foundation, and we have Srđan Vukić with us tonight, talking about a very interesting and increasingly relevant topic, the 5G technology and its role in the current industry evolution. He is a telecommunications engineer who graduated from ETH Sarajevo and has spent the last 20 years in the telecom industry, assuming both technical and management roles. He is currently working for Ericsson Dubai. This time we will have 3 rounds of questions, so I encourage everyone to leave their questions in the live chat. Thank you, Srđan, once again for taking the time to be here.
Thank you, Anna. Good evening, everybody. Maybe even good morning or good afternoon, depending on where you are. So, as Anna said, my name is Srđan Vukić, and I've been in telecommunication industry in my entire career, 20 years, and especially in mobile communications. So all my career I spent exactly there. I've been also as an engineer working in 2G technology, then 3G technology as a project manager, also in 4G, and then now in my last role, which is Techno-commercial Manager, I'm also part of the 5G deployment in Middle East Africa. So I have a lot of firsts in my career, first 2G, 3G data calls in a couple of countries, leading first LT projects rollouts in a couple of countries, and now also I was recently part of the 5G testing showcase in Dubai just some 2 months ago. So I'm quite familiar, and that's basically, mobile communications are in my heart and something I would say in my genes, and I'm really pleased that I have opportunity to share with you what the 5G is, how it is foreseen to shake the technology and industry, and that's why the name of this webinar is 5G Technology and Industry Revolution rather than Evolution. With this, I will move to the content, and we'll have here 3 sections. First one will be a kind of introductory section talking about evolution of digital mobile communications. Second one will be basically a brief comparison between 5G and 4G and what all the hype about 5G is. The key differentiators, some deployment options that might be of interest, especially of the guys who are telecommunication students. And also, I would like to touch up on the overview of current and new services that will be either boosted or enabled by 5G. At the end, I'll talk about the 4th industrial revolution and how it is actually going to be fueled by 5G. Very shortly, what the IoT is and how some of those services and applications are actually happening already now. So, moving to the mobile communication evolution, and you can see basically that we moved from 1G to 5G in 40 years. 1G, what you see in the slide, is basically started beginning of 80s last century, and that were the mobile analog communications. So what we had there is rather large mobile handsets. If you watch some Hollywood movies, you could see guys proudly sitting in their cabrios and carrying a piece of 3 kilos and talking. And that the only service that was possible in that time was a call, simple call. Then end of 80s, actually beginning of 90s, second generation was introduced, and that was the first digital. It was called 2G. Several standards within it. The most popular is the GSM. There, as it was digital, first digital system, we could introduce some additional services like messaging, and also a bit later stage, first access to internet through so-called wireless application protocol, or WAP, which was a predecessor of HTTP that was later introduced also in mobile communications. Next generation started basically in 2000, 2001, 3G, and there you had several technologies. The most known or deployed one is WCDMA. We have witnessed increase in the data throughput. Okay, then by that one we could introduce some also additional services, but the main, I would say, difference was now we have really moved to pre-mobile broadband era. Going further, some 10 years later, we came to the fourth generation, where you have basically two most famous, I would say, standards within it, LTE, and then you have also a WiMAX, which was mostly used for the fixed access. 4G again brought another boost, significant boost in the data throughput, and a lot of new services enabled, but by that increase, video streaming, online gaming, and other things, and of course, introduction of smartphones in parallel was really boosted by 4G, and I would say actually both 4G boosted smartphone development, but also vice versa. So there were a lot of improvements done just by the requests, by the requirements that were raised by the handset manufacturer. At the end, some again 10 years later, and you can see that all these technologies actually have a time lag of 10 years approximately. We have come to 5G, and 5G, of course, again, this side, further improving the data throughput, has some other key differentiators that I'm going to talk about in second section of this presentation that will really change the way we do the things when it comes to the mobile communication technology, but also industry. It's worth to know that there were some intermediate steps between 2G, 3G, 3G, 4G, and so and so. You have something called 2.5G, which is introduction of the GPRS standard for the data services, and also Edge, which is an enhancement in the technology itself, enabling increase in data speed up to 384 kilobits, which is of course funny from this perspective. Then we had also 3.5G, which is introduction of HSDPA, or high-speed download packet access, for increasing data and speed. This is already coming now to, I would say, 48 megabits, which is something significant and really already enabled through mobile broadband. Then we have between 4G and 5G, we have something called 4.5G. It's LTE Advanced, which introduced carrier aggregation, basically aggregating carriers on different bands for the same user, thus enabling very big increase in data throughput, and you could even read somewhere on that those data speeds could reach in some testing environments up to 1 gigabit per second, and that's called Gigabit LTE or LTE Pro. So now I would like to show you how the mobile subscription trends look nowadays. For this, I'm going to use a publication from the company I work for, but it's a publication, so there is nothing confidential, so I am free to share it. And this is quarterly issued, and it's very well respected within the mobile communication community, and something that we can rely with. It's really quite comprehensive and exhaustive exercise done every quarter. So what you see here, this is from the Q3 2019 report. Q4 2019 report will be issued sometime in February this year. You can see mobile subscriptions in million, and also you can see in brackets increases that happened this quarter compared to the previous one. So what we are talking here is basically around 8 billion mobile subscriptions are currently in the world, all right? And every quarter, 61 million, or last quarter, 61 million was a unique mobile subscription addition. What you see here, the number of 6.2 billion, this relates to the mobile broadband subscriptions. So this is basically what I said, 3.5G, 4G, and onwards. What I'm showing now is actually how it is forecasted, how the trend, mobile subscription trend is forecasted up to 2025. What you see on the left-hand side of the graph is 2015, where basically we had a big dominance of 2G, 3G technologies, and 4G was just started, right? And now we are in At the end of 2019, we are talking about what I mentioned, 8 billion subscription, where basically half of them are or 52%, what you see down, belong to LT. What is important to, if you go further to the future, to 2025, you can clearly see that GSM and WCDMA, so main 2G and 3G standards, are sunsetting. In many developed countries, actually, they are shut down or being shut down as we speak. Let's say North America, South Korea, even in India. Couple of operators there already completely shut down 2G, some of them even 3G. Of course, those are the operators that have voice over LTE enabled, so the voice calls still continue. LTE is forecast to achieve its peak around 2021. So let's say maybe 2 more years, LTE will grow, and that's mostly because of the emerging markets like Africa, Latin America, where we still have a space to grow in LTE coverage. And then it will start dropping. All this drops in not only 2G, 3G, but 4G will basically be compensated and even overgrown by the growth of 5G subscriptions. And what you see in the slide is that it's forecasted by 2025 to have 2.6 billion of 5G subscriptions. If you know that by end of 2019, there were only 19 millions, as I said, this was mostly in North America that was first that started implementing the 5G. That brings us to unprecedented growth, compound annual growth rate of 189%. So from 19 million to 2.6 billion in 5 years. And that's something really that is exciting, I would say. Now I'm going to show you how this mobile subscription trends looks per regions. Okay, so what you see here is there are several regions in the world, and we have a current status on the right-hand side of each couple of bars. Sorry, on the left-hand side, that's 2019 year, and then the forecast for 2025. If you start from the right to the left, you can see that North America is obviously the most mature region currently, having like 90% of LT subscriptions, and even some percent of 5G already, as I mentioned. And it is forecasted by 2025 to have 3/4 of subscriptions will be basically 5G, which is really immense. Then you have, again, another developed parts from this perspective. This is, of course, Western Europe and Northeast Asia, where we are going to, by 2025, cross 50% of all subscription to be a 5G. Then the other regions, Latin America, is not, doesn't look so good. I said it's an emerging market. If you see even 2019, they have only 51% of LTE subscriptions. Then you have the Central and Eastern Europe that is worse than Latin America currently, but it's expected to have a bigger uptake of 5G in 5 years, up to the Southeast Asia and Oceania, then Middle East and Africa and India. What is interesting, when you see Middle East and Africa, actually, it looks the worst from the from the current and outlook perspective. However, that's due to Africa. If you see the Middle East itself, especially those most developed countries, or I would say the richest countries in Gulf, they are already in par with North America when it comes to the 5G deployments. And as I said, United Arab Emirates, they have 5G deployed. Saudi Arabia has 5G deployed. Bahrain, Kuwait, 5G deployment is ongoing. Qatar, of course, has 5G deployed already. So it's a quite of diverse region, but blended, it doesn't look so much so good because, of course, the most of population is in Africa compared to the Middle East. So what we want to say here, you can see a big shift in the subscriptions, and this is what I said, that there is unprecedented growth forecasted for the 5G. It's so attractive. Once it becomes affordable, of course, all new technologies in the beginning are a bit more expensive. It will really grow, and I would say explode. So with this part, I would now close the section 1 and open the floor for questions. So back to you, Anna.
Well, it seems we don't really have any questions yet. I'm gonna give them like a minute or two
Sure.
to make sure. But if anyone has any questions, now would be the time to ask. No, nothing. I guess we don't have any questions yet.
Okay, thanks. Then I'm gonna move on. And of course, just to mention, if
Wait, we have one.
yes, sure.
Uh, what kind of resources do you need to implement 5G? I think that actually leads to the next section.
Yes, I'm going to cover this in the next section. So if you please hold on, and then after I present next session, if you still have this question or something around it, feel free to ask. Okay. Are there any other questions, Anna?
Nope. No.
All right. Then
Oh,
let
wait,
me
wait.
let me.
Ogden says one question and I'm waiting for him to type it out.
Sure.
Oh, okay. So the question is, when can we approximately expect high frequency 5G to be widely available?
Okay, I'm going also to cover that part in the second section when I will talk about devices. Okay, and when the devices will be available. When we talk about high frequency, I presume we are talking about millimeter wave. So these are the frequency from around 30 gigahertz onwards. All right, and as I said, this will be in the second section. So please hold on your horses. I'm gonna go talk about it, and then feel free if you are not if your question is not fully answered by the time, feel free to repeat or to put sub question.
Okay, then I guess we can proceed then.
All right. So this is actually the part when we talk about the deployment options and migration scenarios. All right, and I'm going to I believe answer first question by talking about it. So what we have here is it's a bit of busy slide, okay, and these are all the deployment options. All right, and I'm going just to open all the things, put all the text here to understand what it is. Basically, currently, what is being deployed in the world is so-called NSA or non-standalone 5G. You will also see NR. NR stands for New Radio. What does non-standalone mean? It means that it has to be anchored to LTE. So we do not have still 5G core ready. We are still using EPC, Evolved Packet Core, that is used for LTE with certain software additions. All right, and LTE is used as an anchor for the control layer. So practically, this would also mean certain restrictions. For example, if vendor A has implemented LTE at certain site, vendor B cannot implement 5G or NR on that site. It can be only vendor A. This, of course, works well for vendors, doesn't work so well for operators because they don't have real competition when it comes to the 5G deployment. However, however, sooner than expected, okay, we will move to standalone. Okay, standalone will basically mean that there will be no relation between the 5G node B called GMB, all right, and LT node B called EMB. They will be you'll be able to make an completely independent overlay of 5G over 4G sites. All right. Initially, or let's say just like 6-7 months ago, everybody was talking about uh, standalone standard to be deployed in 2021, but actually we are bringing it forward because of the demand, and it seems it will happen in H2 2020. And just recently, actually, I worked one commercial proposal here for the operator in United Arab Emirates about standalone 5G. So what are the migration scenarios? These are the options available to the operator. So you have different options down how to migrate from current status, which is basically option one. You just have a LT node connected to evolved packet core, and how to move, to different options. You can even use LT. You can either use LT to anchor 5G. There are also deployment options to use 5G to anchor LT when you will have 5G core. Okay, what is important to know? Without 4G in the network, you cannot have 5G currently. All right. So let's say if we reflect this to Bosnia, last year we we implemented first LT network in Bosnia, right? So basically, from that perspective, with some certain software upgrades in the core part and maybe on the radio part, and depending, of course, on the vendors and the state of their equipment. If this is the latest one, it's the addition of 5G would be rather swift. So from that perspective, we can say we are ready also to adopt 5G, and I certainly hope that the lag between 5G and 4G will not be as big as between 4G and 3G, because you could all enjoy the benefits and see the clear difference in quality of service in data speed and between 4G and 3G. And then, when you moved from 4G to 5G, this difference will be, if not, it will be, in my humble opinion, it will be bigger because of some other characteristics of 5G I'm going to talk about. So just to go back to the first question, does this answer the question, or there is something else?
There was like an addition to the question in terms of the country, as in the terms of. Wait, let me just read it. He says, I mean, as a country, what kind of resources would we need to implement 5G? So I believe he's referring to Bosnia.
Okay, so if you let me put it from the technology perspective. 5G is using the same frequencies as LT. Okay, so from the spectrum allocation or whatever, there could be a strategy to either share the spectrum, certain spectrum allocated to a certain operator between LT and 5G. Okay, or there is a dynamic spectrum sharing software functionality that will be available this year for at least a couple of telecom vendors will be able to deliver it. So on top of it, there will be, as I said, millimeter wave, which is called also high band. These are the frequencies in range of 30 gigahertz. The most popular bands are now 26 and 28 gigahertz. And that's something that may need, of course, licensing, and RAC will have to do the auction and allocate the spectrum for the high band. But you can start with the low and mid band. Basically, low band is up to 1 gigahertz. Mid band is called everything beyond 1 gigahertz to 6 gigahertz. So I really don't know which frequencies are used currently for LT in Bosnia. However, on all those frequencies, 5G is using the same frequency, same bands, and as I said, it's rather swift upgrade or addition of the 5G in most of cases.
All right, we have other questions, but we can take them after the second segment since they're all related to 5G.
Right. Okay, then let me talk about the key differentiators. All right. So I put here this graph with rather reservation. All right. However, do not stick with these numbers, okay? But I want to mention what are the key advantages. Let me start, clockwise from left, top corner around. So first, the decrease in latency. 5G is planned to deliver a latency of in range of 1 millisecond. Okay. Currently, LT working scenarios, it's around 50 milliseconds. I mean, when you see 1 millisecond or 50 milliseconds, that's something that we can hardly feel. However, in mobile communication, it's a huge difference. Okay. Another important thing is connection density, and that's one I will mention what the key differentiators between the two technologies are, in my opinion, and what we see here, and how it will be developed further. So basically, it says that 5G will deliver more efficient signaling for IoT connectivity. Then the one that is basically for the common or regular user, the most attractive one is the increase in the throughput or data speed. Talking about 10 times, you will somewhere see on internet it's 100 times, but I'm going to talk a bit more about all this when we go through. Network efficiency is important thing, especially from industrial perspective, industrial applications. Okay, that's about energy consumption. Traffic capacity, it's immensely important for IoT. I'm going to talk about it. Okay, and then spectrum efficiency, it's basically a better usage of available spectrum from many perspectives, from the overhead perspective, from the bit per hertz and all other parameters, and this is in close relation to the increase in the data throughput. Now, let me mention the three key differentiators are, of course, increase in throughput, reduction of latency, and increase in connection density. Again, what I want to repeat, don't stick with these numbers. 5G technology is still evolving. If you just see that last year there were several releases, 3GPP releases related to 5G, and I think we are still on learning curve in a way, all right? And all these numbers may change. Hopefully, will go up. Some of them may go down. When we talk about throughput increase, 5G, as I said, no, I mean regular 5G, regular LT can deliver around 100 megabits. With carrier aggregation, with this super aggregation of 100 megahertz of spectrum, something, it can come even to 1 gigabit. This is what I mentioned, but that's more in test environment than in the real life. 5G can go up to, let's say, 10 gigabits, we would say now, foreseen, and that's only on the millimeter wave, basically on frequencies of 30 gigahertz, where you can you can avail around 800 megahertz of spectrum in this band. Okay, and so as it evolves later, as if you go to the higher bands, maybe to more than 60 gigahertz or whatever, the available spectrum will be higher, and then you will be able to enjoy even bigger speeds. However, there is a downside of it for all the telecommunications students. They know that higher the frequency, shorter the coverage of signal loss is bigger. So it means that it would result in building a lot of sites very close to the users. Okay, this like a lamp post or a lot of indoor sites in let's say shopping malls, in even in dense urban areas. I said those lamp posts or other solution that would be maybe just few tens meters away from each other. Okay, so now I'm gonna switch to the 5G device status and outlook. So as I said, you can see on the left-hand side of the graph, there are currently three bands where 5G is planned to be deployed. Low band is up to 1 gigahertz. Okay, mid band is up to 6 gigahertz, and millimeter wave is, let's say, starting from 26, but then even to 39 gigahertz, and that's basically, it may even grow further, or basically going for higher frequencies than this. You could see that in 2019, okay, we had mostly a packet routers, few smartphone attempts, I would say. They did work, and I've seen also, let's say, Oppo smartphone that we did testing in Dubai a couple of months ago, delivering around 900 to 1.2 to 1.4 gigabits. Okay, of course, in test environment, but it's still a really good result. Uh, However, in first half of 2020, we will experience the boom in second generation of 5G devices. All right, and in all of them, you will have, and in all bands, you can see how dense it becomes. Those icons for the high band and the mid band. So we are talking about the pocket routers, smartphones, and CPs. Basically, these are the customer premises equipment. All right, that is used mostly for the fixed wireless access. Just for you to know, most of major smartphone suppliers already have 5G capable devices. Okay, of course, for selected bands, and now they are going to grow and across all the bands. And in this case, as the availability of spectrum and the availability of devices on those bands will drive also on network deployment, network rollout. The only exception of those major smartphone suppliers is actually Apple. So it is forecasted that iPhone 12 will be the first 5G capable phone, I think second half of 2020. While let's say Huawei, Samsung, Oppo, One, they all HTC, sorry, they all already have 5G capable handsets, and actually here, for example, in Dubai, there are a few of them already available to be, in the market. What I want to mention is the complexity of 5G smartphone design will increase immensely compared to 4G capable phones. First, because of all these requirements on the throughput, on the new services, low latency, but also if you see the spectrum span, if you expect that you will have currently your smartphones, 4G smartphones, cover all those bands from, let's say, 700, which is the lowest band used in LTE, up to 2600 or even 3500, which is rare currently for LTE. However, just building the components that will cover the bands from 700 megahertz up to 39 gigahertz, it's really a complex thing. So of course, increase that those smartphones will be more expensive than 4G, like every new generation is, but with the mass production, it will become more and more affordable. Now I'm gonna switch to the overview of current and new services. All right, and what you see here is a graph where on the y-axis you have a delay in milliseconds, starting from 1000 milliseconds or 1 second up to 1 millisecond or even shorter, and on x-axis you have the bandwidth throughput, or let's say data speed, starting from less than 1 megabit up to more than 1 gigabit per second. Then there is number of services or applications that we have now that are currently supported by legacy technologies or can be delivered by legacy technologies and networks, and they are in this white rectangle. And then around them, you see some new services that could be enabled by 5G. Okay, so I would say that 5G first will significantly enhance a number of existing services. For example, real-time gaming is a service that can be delivered by LTE. Okay, it takes like 10 megabits per second, 10 milliseconds. But can you imagine how real it will be if you move to, let's say, 500 megabits per second and 3 milliseconds of delay or latency? Okay, so some other things when we talk about monitoring sensor networks, this is the I would say the dot down. It doesn't take, it doesn't need any speed. 1 second is enough. It doesn't need any data throughput, but the density, traffic density, and capacity of 5G network is expected to grow few tens and even up to 100 times. So even by implementing 5G there, it is going to boost even this kind of service or application, even though it can be easily catered now from the requirements perspective by legacy technologies. So again, I want to repeat what are the key 5G enablers as compared to 4G to boost existing services and to help introducing new services. Throughput, low and ultra low latency. Ultra low latency expected to be on the millimeter wave because of higher frequency and specific data frame structure in 5G technology as compared to 4G. Keeping in mind again, just a small digression. 5G, from the technology perspective, modulation, then frame structure really heavily leverages on 4G, on LTE in particular, and it enhances it further. Okay, so all these enhancements from perspective of data speed increase or throughput increase, latency decrease is based on enhancement of the existing techniques used in LTE. Okay, so that's basically that's why I mentioned three key differentiators again: throughput, latency, and capacity. Another thing is something that is becoming extremely important. You could see a lot of fuss going around about security. It's so-called one application, so-called Tactile Internet. What is Tactile Internet? And you can see it in the top right corner. Tactile Internet, you see, it needs high throughput and very low latency. It's a combination, by definition, it's a combination of the low or ultra low latency and high availability, reliability, and security. It will be extremely important in the Internet of Things in so-called critical IoT part that I'm going to talk about later. Okay, and of course, since it is expected, 5G is expected really to come into all segments of industries, of most of industries, these things, availability, reliability, and especially security, become of essential importance for deployments. Okay, so let me just mention a couple of interesting services that some of them exist now, but will be definitely boosted and improved by 5G. For example, augmented reality. What is it? It's a technology basically that combines the real world environment and computer generated input. So it kind of overlaps, take the computer generated input and put it into the real world environment. All right. And then these two parts can interact together and can basically be digitally manipulated. What does it mean? You can see here a number of applications that fall under AR umbrella. In the industry, you can say guided trainings. For example, in healthcare, you can have like, I don't know, 3D view diagnosis techniques and other things. In retail, you can have several services. Let me just show you some of them here in the pictures. For example, in the retail, you can just pick the suit from certain shop and see how it looks like on you. All right, or you can take a piece of furniture and put it in your sitting room and see how it looks like. Gaming, something that you may be very much related to, is Pokemon Go is AR application, because you are actually chasing the Pokemons in the real-time environment, right? You go after them, you follow them on your phone, and you go back and forth, left and right, until you catch them. Then you can see some sport application. Of course, you've seen different techniques already implemented when you check the offside, and all these 3D animations, moving the pitch and the players around just to have the best angle, up to several industrial applications, like how the building you want to construct will look like in the environment, or tourism, going through, I don't know, browsing through the hotel rooms, facilities, and also healthcare, as I said, 3D diagnostics, and many, many others. So augmented reality is really an attractive one, all right? And the question is, how will 5G boost AR service? This service, augmented reality, these applications are already there. We will get more, but those are going really to experience explosion in usage, because you will be able to experience them on our mobile phones. So it will reach out huge number of consumers on the go, okay? And as I said, this is to truly increase the capacity in terms of connected users, increase throughput, and true real-time experience due to low, or let's say negligible, latency. The next service that is becoming really very interesting, and of course opens a lot of debates about security, reliability, is autonomous vehicles. So what does it mean, and how 5G will boost it? What is autonomous vehicles? These are basically a self-driving vehicles, right? So they are equipped with tons of sensors, and those sensors will interact with entire surrounding, with other vehicles, with pedestrians, with traffic lights, with buildings, with anything else that is on the road, and also to the network. Okay, so you have see some examples: robot taxis, autonomous transport fleet, basically driverless taxis, right? So you arrive by plane to some place, and you go out, and there is a taxi without driver. You just say where you want to go, and taxi will take you. You can relax. Hopefully, you can relax. Uh, how will 5G boost autonomous vehicle service? I mean, first thing which is characteristic for vehicles is mobility, and 5G provides you mobility. And so, in the entire autonomous vehicles ecosystem, you will need 24/7 connected vehicles everywhere and every blink of an eye. So, if it's a self-driving vehicle, it has to always be aware of whatever is going on around it, and even in front, or even if there is, as I said, some uh, obstacles on the road or diversions, whatever. So this cannot be delivered by 4G because primarily of latency and and capacity in terms of connected simultaneously connected users. Okay, that's why the autonomous vehicle service can be truly enabled only using 5G. All right, so with this one, I would close the section 2, and of course, I will again open floor for questions.
We have several questions. The first one being that I heard a few days ago that every country that is a part of the European Union must have 5G deployed in at least one city. My question is, could we deploy 5G during this year in one of our cities, let's say Sarajevo?
Well, as I said, currently the fundamental requirement for 5G deployment is existence of 4G network. So I presume there is 4G in Sarajevo.
Yes,
Okay.
yeah.
So I don't, and since 5G is using the same frequencies, the same spectrum like 4G plus some more, I don't see any technical obstacles to implement swiftly 5G.
The next one is, are there any health related issues with the high frequency bands of the 5G?
Okay, so that's another thing that there is a hype about for 5G. I'm not a doctor, I'm not a biology scientist, but I'll tell you one thing. 5G is using same frequencies and same modulation techniques and everything like previous legacy technologies. So another thing is electromagnetic waves used in mobile radio falls into non-ionizing radiation, which that's the radiation that basically doesn't harm your molecules. Okay, it's a low energy and it doesn't ionize your atoms, meaning breaking your molecules. Unlike the other kind of radiations like gamma rays, X-rays, you all know about, and you all know about how harmful they can be if you are exposed on higher dose and whatever. So as long as 5G systems comply with World Health Organization and other organizations limiting the electromagnetic fields levels, I don't see a reason to be afraid. Everything else falls in the domain of speculations. So it doesn't matter if it's, let's say, 2.6 gigahertz frequency or 26 gigahertz frequency. Okay, if you are within the levels, allowed levels of radiation, okay, there are no confirmed studies about, or there are no studies confirming harmfulness of mobile communication radio waves.
Okay, and next we have an expansion on one of the previous questions.
Yes.
Ognin says regarding the high band millimeter wave and the challenges in deployment, is there an easy way to overcome the problems and avoid the high band antennas in each block?
Simple answer is no, because you cannot confront the laws of physics. Okay, and if you see the formula for the radio propagation, okay, the length of propagation is disproportional with the frequency. So higher the frequency, lower, bigger the loss of the signal, meaning shorter coverage and shorter propagation of the wave. So that's the biggest challenge of the deployment of the millimeter wave 5G. You need to build sites every tens of meters. Okay, and recently, actually, we and other company deployed some millimeter wave for the fixed wireless access in US, and basically reactions from users were like, okay, I see the post, I see the radio, that is basically turned towards my house and other 3 houses, to deliver this whatever 200, 300 Mbps per user or whatever they signed up for. So we cannot overcome this. As I said, it confronts the laws of physics.
There's another one in regards to the technical aspects. Does the geography of Bosnia and Herzegovina represent an issue in 5G deployment due to the numerous hills and mountains?
Well, I would not see here a difference between 5G and other technologies. Okay, if you talk about high band, let's say the bands where you are going to really deploy high data speed, they will be deployed in urban areas, in big cities, not even in Sarajevo everywhere. Maybe you will deploy it in, I don't know, in center, in Baščaršija, but maybe not in I don't know, in Pofalići or I don't know, some other part. So it's very important to know where you want to deploy what. So Bosnia is not the only country with mountains, okay? And as I said, propagation of the 5G wave is no different than propagation of 4G wave. There are certain techniques also being deployed in 5G called carrier aggregation, where you are going to have basically you are going to have so-called coverage band, let's say low frequency, higher propagation, let's say on 800 megahertz or 900 megahertz, and then you are going to have a higher band for capacity, and these two will interact. So wherever you are able to get the coverage of the low band on 5G, you will be able to experience higher data speeds than only on that one by aggregating it with 2.6 gigahertz carrier that you cannot maybe directly get coverage from there, but with certain techniques you can get enhancements in data speed. So in other to sum up, whatever is valid for 4G, it's valid for 5G. Millimeter wave is exception, and it will be deployed in real dense urban areas and even hotspots.
Okay, and lastly, we have a bit of a longer question in regards to security. How will the usage of 5G improve the security when it comes to data transfer? Isn't 5G supposed to improve computing power, thus making some algorithms/methods used for safe transfer of data and that rely on the time itself less reliable?
Yes. Okay. I won't be able maybe to provide a detailed technical response, but there are a lot of questions about security of 5G. Why? Because 5G is supposed to penetrate into industry much more than 4G ever did. Another important thing is that unlike 4G, a lot of computing power, okay, has been moved to edge, meaning to the radio nodes. While in 4G and of course previous legacies, most of it was done in the core nodes, okay? This means that 5G becomes more exposed to security because it's threats because it's more difficult to control it. Before you control the core node. If you control a core node, you are 99% safe. Okay. Now implementation of algorithm, and you know how this works. There will be many releases. There will be many security improvements. It's like a thief and a lock, right? Thief finds a key, then you make a new lock. Then thief finds the key for that lock, and it goes and goes like this. Yes, there are challenges just because, but there is at the same time this really big focus on security just because of the planned deployment of 5G, what I mentioned. So if you would like to get more on this algorithm and how this 5G technology impacts its implementation, I will try to search something about it within within my resources, okay, the company I work for, okay, and so let me know. I mean, you will get my email address at the end, all right, of the presentation, or it will be shared. So if there are any questions that you are not satisfied currently with the answer, okay, send it to me, and I will really try to dig in for details.
Okay, we don't have any more questions at this time.
Okay. Then let me move to the third and last section of this presentation. It's about fourth industrial revolution and how it's fueled by 5G. Okay, this is a brief overview of all industrial revolution. Now their fancy name is Industry 1.0, 2.0, and so and so. So first one started end of 18th century, as you know. Mr. James Watt invented the steam power machine. Okay, and you can say that the first industrial revolution was fueled by water and coal, right? Then some 100 years later, we are moving to the second industrial revolution that is fueled by electricity, but also gas and oil become basically a main resources uh, in entire industry. Okay, this is characterized by the mass production, assembly lines, and other things. The third industrial revolution happened some 50 years ago. Okay, and it's basically fueled by the electronics. You know, when transistors started to develop in first in 1950s, then they they experienced explosion in 60s and so on. So everything related to the automations, even some first attempts of robotics have started immediately afterwards. Now we have come to the fourth industrial revolution, okay? And actually this is where we are today. So we are in the midst of the fourth industrial revolution. It is characterized by the cyber physical systems, quite autonomous, Internet of Things, and networks. Why I have ambitiously put here fueled by 5G is basically many things that I've said so far, and a few more things that I'm going to say. So I truly believe that the fourth industrial revolution will be really propelled in coming years by 5G. IoT is one of the fundamental parts of the fourth industrial revolution. You all know what it is, and basically, to make it really simple, it's connecting everything to everything. Okay? So let's talk about IoT fueled by 5G. I believe that there was recently a webinar on IoT, so I'm not going to talk much about it. Okay? I will talk more about from perspective of the mobile communication technologies. So we have two main categories of IoT: massive IoT called MIoT and critical IoT called CIoT. There is also some categories, broadband IoT and so and so, but these are the two main ones that everyone can relate to. Massive IoT, you can see it on the left-hand side of the graph. Basically, it's logistics tracking and fleet management. I don't know, smart meters, smart agriculture, all these things, measurements mostly. It's characterized by low cost devices, by low energy consumption, small data volumes, massive numbers, and of course, latency requirements are very flexible because this is not something that you need real time. You are mostly collecting the data from many points. Okay, data is simple. You do not need much. Actually, it doesn't. The volumes are low. Okay, but those, since you have massive number of those points and devices, they have to be very cheap, and their energy consumption has to be low. On the right-hand side, you have a critical IoT. Critical IoT is characterized by very low latency or ultra low latency, ultra reliable, and very high availability. Of course, we say the throughput itself does not have to be always main characteristic of critical IoT. Okay, but these things, reliability, availability, and latency, are really the essential parts of it. We are talking about remote healthcare, remote surgery. We talked already about autonomous vehicles and also industrial applications controlling robots or machinery, from one side of the world to another one. And this you cannot afford to have delays or interruptions in connections. They could lead to disastrous results. Even in military, if you play with some, let's say, heavy weapons, and there is some glitch in the system, of course, it can be a disaster. So 5G will boost existing massive IoT applications. As I mentioned, first, increased traffic density. So with 5G, there was some comparison recently done saying that, let's say, if site with LTE can cover, I don't know, 2,000 devices within 1 square kilometer around it, that uh, same site with 5G can cover a few hundreds more. So 300,000-400,000 devices. So and I said, don't stick with this number, but this is basically how it may look like in a year or two, because 5G is still evolving, and it will still be evolving for a couple of years before it reaches a real mature status. It doesn't mean it will be saturated, it just means it will be mature. So that's why I'm saying 5G will boost existing massive IoT applications, definitely, most of them. At the same time, those critical IoT applications and services are not possible without 5G. They are just not, 4G cannot support them. Okay, so with this regards, I'll just show you basically this is something that you can easily Google out. First remote surgery done in China, okay, using 5G technology. Basically, when you have a surgeon sitting in a place and having this smart glove or smart gloves, and then, I don't know, 50, 70 kilometers away, there is a surgery hall with a robot, and with animal, but then they even did the brain surgery later, okay? And this robot, does the operation the way surgeon moves his hands, right? And the other thing is that he has also this augmented reality part into it. They can see really inside everything what's going on. He can augment the picture, he can augment the organs and everything. So this is happening, and it has happened already, and it will be happening more and more. So again, for this kind of 5G applications, we know that latency, right, and reliability and availability are key, because any glitch in those parameters really may lead to little results for patient, right? So then we have 5G connected vehicles. A lot of tests have been done. I've seen even something that my company has been involved in. It's really, it looks like science fiction when you see how it is. And these are the real life tests. This is now, of course, to have truly autonomous vehicle ecosystem, you need to have 5G sites everywhere, right? If you want to do it, let's say in New York, you need to cover New York by 5G. It's not an easy task. But what I want to say, the tests are being done in controlled, in small environments and regions. It's working. It's working well. AR, VR things. This is now becoming really, a real boost, a real game changer, and it's becoming more and more. And you will see in coming months more applications available on mobile handset, more applications that really have tougher requirements than those on 4G, and this will be exploding in a couple of years. So with this, just to mention a few key takeaways. 5G, I would again repeat, revolution is happening as we speak. Let's embrace it. Second is the era of digitalization we are in, and we have been in for, let's say, a decade at least, will be further catalyzed, I would say even propelled by the 5G. And second and last thing is the 5G will become the true circulatory system of many industries. It will be there, it will carry the blood of those industries to all parts of it. So with this, I would end up my presentation. Again, I would open the floor for questions on the third section, but any other question that may pop up in between related to the previous sections. Anna, back to you.
I will give it a minute or two in case
Sure.
anyone has anything to add. Well, I guess that was it. I guess we don't have any more questions. Thank you again for sharing your knowledge with us. I believe we all learned a lot today.
Thank you very much to you and to all participants for your time and participation. And as I said, I'm really pleased to have this opportunity. And of course, I hope we'll continue our collaboration. And if some other interesting topic from my domain pops up, I will be very glad, to support it, to do another webinar. Thanks everybody, and please feel free if you think of some questions or something that was not explained till the extent you expected during the presentation, and I will share my email address. You can drop this question. I will try to answer as soon as I can.
Thank you so much. Have a good night.
Thank you. Good night to you all.